Sai Ram children, welcome to online session. We'll continue with our chapter area. Let's revise what you learned in previous session. We have covered parallelogram, rhombus and now trapezium. What is a trapezium? A trapezium is a quadrilateral having one pair of opposite side parallel. Area of trapezium. Area of trapezium formula is half into sum of the lengths of parallel sides into height. Let's continue with practice set 15.3. Second sum. Length of the parallel sides of a trapezium are 8.5 cm and 11.5 cm respectively, and its height is 4.2 cm. Find its area. So we'll solve the sum. First, given. What is given? Length of the parallel sides. And length of the parallel sides of a trapezium are 11.5, that is 8.5 cm and 11.5 cm. So length of parallel sides 8.5 cm and 11.5 cm. This is given. What we have to find? We have to find area of trapezium. So solution. First, what we will write? Formula. Area of trapezium. So what is the formula, children? It is half into sum of the lengths of parallel sides into height. Formula of area of trapezium is half into sum of the lengths of parallel sides into height. Now it is substitute the values. Half into, now length of the parallel sides is given. It is 8.5 plus 11.5, and that we have to write in bracket. Into height, height given is 4.2. So as we know BODMAS rule, we will solve the bracket part. So we will add 8.5 plus 11.5. So add, children, 8.5 plus 11.5. The answer is yes, 20. So the next step will be half into 20 into 4.2. So now half of 20. Half of 20 is 10. We know that 2 tens are. So half of 20, that is 10, multiply with 4.2. So when you multiply 10 with 4.2, your answer will be, that is 42 square centimeter. How you can do? If you ignore the decimal, you are just taking 42 into 10, it comes 420. Then one decimal place. So that is removed. So only the thing you have to remember is 10 multiplied with 4.2 is 42 centimeter. And if you are able to do directly, good. Otherwise, you multiply and check. So the final answer is area of trapezium is 42 square centimeter. Okay. Now, this is an isosceles trapezium. Now, what is isosceles trapezium? Isosceles trapezium is a trapezium whose non-parallel sides, these are known as non-parallel sides, which are congruent or equal in length. Like we know isosceles triangle, a triangle having two sides equal, that is isosceles triangle, a triangle having two sides equal or congruent. Now here it is isosceles trapezium. So we know a trapezium has one pair of opposite sides parallel. Now which side is parallel? AB is parallel to CD. So which is a parallel side? Side AB is parallel to side CD. So these other two sides, which is AD and BC, they are known as non-parallel sides. AD and BC are known as non-parallel sides. And when the length of these non-parallel sides is congruent or they are equal in length, we call it isosceles trapezium. So here in isosceles trapezium, this AD and this BC are equal. Side AD, side BC are equal in length. So this is isosceles trapezium. Question 3. So this sum is from practice set. Quadrilateral PQRS is an isosceles trapezium. Length PQ is equal to 7 cm. Segment PM is perpendicular to segment SR. Length SM is 3 cm. Distance between two parallel sides is 4 cm. Find the area of quadrilateral PQRS. So here we have to understand what is given. First thing is PQRS is an isosceles trapezium. Now what is an isosceles trapezium? Isosceles trapezium is a trapezium whose non-parallel sides are congruent or equal in length. So here also the given quadrilateral PQRS is an isosceles trapezium. Now isosceles trapezium means side PQ is parallel to side SR. So this is one pair of opposite sides, side PQ parallel to SR. Non-parallel sides are PS and QR, and these sides are equal in length. It means PS is equal to QR. So it is an isosceles trapezium. Then what is given? PQ is 7 cm. It means one side, that is one of the parallel side, is 7 cm. And segment PM is perpendicular to SR. Now segment PM is perpendicular to SR. It means this is the height of the parallelogram. The distance between the two parallel lines, that is the height. And SM is 3 cm. So this part is given SM, and that is 3 cm. Distance between the two parallel sides is 4. This is PM, which we have said earlier, it is perpendicular to SR. And this is the distance between two parallel lines, which is 4 cm. We have to find area of quadrilateral PQRS. So we know that the formula to find area of trapezium is, that is, it is half into sum of the lengths of parallel sides into height. So which are the parallel sides? Side PQ and SR. Side PQ is given to us, which is 7 cm. SR is not given. Is SR given side? No. Only a part you can say this, that is SM is given. We want SR, sum of the parallel sides, into height. Height is also given. Now we have to find the length of SR. So this is that before starting the sum we have to understand what is given, because we have to find area of quadrilateral PQRS, and PQRS is an isosceles trapezium. But to find the area we have to find the length SR, and for that also we have to follow the steps. So let's continue. First thing is given. Now what is given? Quadrilateral PQRS is an isosceles trapezium. Length PQ is 7 cm. Length SM is 3 cm. Distance between two parallel sides, we also write H for that, the letter H, is equal to 4 cm. So first write given. First thing, it is an isosceles trapezium. Length PQ is 7 cm. Length SM is 3 cm. And distance between two parallel sides is 4 cm. What we have to find here, children? We have to find their area of quadrilateral PQRS. So solution. Now directly if we apply the formula, we will not be able to solve because SR is not given. So for that we have to follow these steps. First thing is, in the given figure we are doing one construction. And which is this construction? This is the construction QN. This is segment QN which we are drawing. It was not given. Perpendicular to SR. Segment QN is perpendicular to SR. So this is a QN perpendicular. We are drawing it. And as we are drawing it, we are calling it construction. So our first step is, let segment QN be perpendicular to segment SR, and the whatever we write in the bracket is a reason or what it is. So it is construction. Then why QN is perpendicular? It is, we have constructed it. So in bracket what we write is, that is construction. And next is, what is given is PM is perpendicular to segment SR. It is given. So what we will write here in the bracket? Given. So segment PM perpendicular to segment SR is given and segment QN perpendicular to SR is construction. Now QN is also perpendicular to SR and PM is also perpendicular to SR. So we can say both PM and QN are perpendicular to the segment SR. Yes? Yes. So when two segments are perpendicular to the same one, they are parallel. So we will write segment QN is parallel to segment PM. So what is the relation between PM and QN? They are parallel. And this is a symbol of parallel. When you write like this, it is a symbol of parallel. If we write like this horizon, it becomes equal. And if we write like this, it becomes parallel. So the relation between PM and QM is they have become parallel. So we will be writing here segment QN is parallel to segment PM. And that's why in bracket we have written this reason. Segment QN and segment PM are perpendicular to segment SR. Both are perpendicular to same segment SR. That's why QN and PM have become parallel. Now, as we have seen, PM and QN segments have become parallel and they are distance between two parallel lines. Segment PM and QN, they are between the two parallel lines. So they are the height of the trapezium. And what are parallel lines? Means parallel sides. That is the sides that is they do not intersect each other. So when we use the word parallel lines, lines which do not intersect each other, same way they are distance between two parallel sides. So this is nothing but the height of the trapezium, that is QN, and PM will become equal in length. So segment QM, that is segment QN and segment PM are equal. Segment QN and segment PM are equal. So first thing what we have seen, that PM and QN have become parallel. Now what we have seen, there are distance between two parallel lines, so they are equal in length also. So segment PM is equal to segment QN is equal to 4 centimeter. And in bracket this number indicates that this is the second finding. First finding we said PM and QN have become parallel. Now they are saying they are equal in length also. PM equal to QN 4 centimeter. So this number we write, so it helps us understanding the problem, and that is they are equal in length and the length of both is 4. PM is 4, it is given. Now QN have also become 4. Now further. So now we can see this PSM, quadrilateral P, that is triangle PSM. Only see this part of the triangle, children. PSM, it is a right angled triangle, and in this triangle PSM, which is a right angle M, this is the angle which is right angle. So angle PMS, this is our right angle. When we say right angle means its measure is 90 degree. And now what we will do by Pythagoras theorem, and we have studied Pythagoras theorem. In Pythagoras theorem, what it is, hypotenuse square is equal to side 1 square plus side 2 square. So here when angle M PMS is 90, so which is the side opposite to it? PS. So here our hypotenuse is PS. So hypotenuse square, length PS square, side 1. So I can take one side, that is PM. This is my side 1. So PM square plus side 2 SM square. So length, that is PS square, is equal to length PM square plus length SM square. Now length PS square is equal to, substitute the value. We know this PM it is given 4 and SM is 3. So 4 square plus 3 square. Now we have to solve. Length PS square is equal to square of 4, children, 16. Square of 4, 16, and square of 3, 9. So we have to add 16 plus 9, and length PS square is equal to 16 plus 9, 25. But we have to find length PS. So how we will find? By taking square root. So length PS is equal to 5. That is how we got it, by taking square root. Now we have seen it is an isosceles trapezium. It means non-parallel sides are congruent. So we got PS as 5. So QR is also 5 centimeter. And because the reason is PQRS is an isosceles trapezium. And we have also got segment QN is 4 centimeter from 2. So we will see this. Length PS, which we got 5 centimeter, is equal to length QR, which is also 5. Why they are equal? Because they are the non-parallel sides of isosceles trapezium. And we have seen PM is 4, so QN is also 4. Now here we are having another right angle triangle. You can see here, children, here is another right angle triangle, and name of this triangle is triangle QNR. Is a right angle triangle. And in triangle QNR, which is our 90-degree angle, N, 90-degree angle is this, children, here, this one, N. So this is this N, which is our 90-degree angle. So angle QNR is 90-degree. Now side opposite to 90-degree is hypotenuse, and which is that? QR. So by Pythagoras theorem, we will write length QR square is equal to length QN square plus length NR square. So this is hypotenuse square, which is this QR, and which is this one side QN and NR. Now what we will do, we will substitute the values. QR we got, it is 5 square, is equal to QN we know 4 square plus NR square. So square of 5, yes, 25. Square of 4, 16. So 25 is equal to 16 plus length NR square. Now what we will do, we have to find length NR square. So 16 we know will go to the other side of equality, it will become subtraction. So 25 minus 16. What is 25 minus 16? 9. 9. That is length NR square is 9. So what we will do? Take square root. So by taking square root of 9, that is 3. So length NR is 3. How we got it? By taking square root. These number indicates these are the findings or the values we are getting. It helps for understanding the problem. That is sum. Now here you observe properly, one quadrilateral is formed PQ, and M, or we can also say P, M, and Q, either clockwise or anti-clockwise. You have to name in order. So see this rectangle properly, children. It is P, M, N, Q. This is a rectangle. Why it is a rectangle? Because we have seen that PM is 4, QN is also 4. And angle M is also 90 degree, angle N is also 90 degree. And this is PQ is parallel to side, that is SR. So this part PQ and MN are also parallel. So here it is formed, rectangle is formed, a quadrilateral whose each angle is right angle we know. So 2 are 90, remaining others also will become 90. This is the rectangle. So at this stage, here in this stage we have to just remember quadrilateral which is formed PNQ is right, that is rectangle. So at this stage, children, just remember this quadrilateral PMNQ is a rectangle. And rectangle has length and breadth. That is, one is you can take PQ, one is take that is PM. So I have written here PQ is not equal to PM. Length PQ is not equal to PM. So now you remember this quadrilateral which is formed is a rectangle. And we know opposite sides of a rectangle are congruent. So PQ is equal to MN, which is 7 centimeter. The reason opposite sides of a rectangle are congruent. So once again this step, children, quadrilateral P, M and Q is a rectangle because we have got segment PN and QN congruent and they are parallel. So they are parallel also, congruent also, and these base angles are right. And PQ is equal to MN. PQ is 7, so MN is also 7. The reason opposite sides of a rectangle are congruent. Now you see the children this part, that is SR, because all these calculations we have done was for SR. That is SM was given 3, MN we got 7, and R is also 3. So this length SR is made up of length SM plus length MN plus length NR. And the reason is these points they are in a line, and that is they are in this on the same side, that is on SR, and they are, how would we write S dash M dash N dash R? This is showing betweenness, they are in a line. S, how we write this? S dash M. It means these points are between. So this we have to just remember, that S dash M dash N dash R, it means points M and R between S and R. So this is a way of presentation. So we write like that. Okay children, now length SR is equal to SM plus MN plus NR. Now substitute the values. SM is 3, MN is 7 and R is 3. So add children now these values. 3 plus 7, 10. 10 plus 3, 13. SR we have got now 13 centimeter. Now area of trapezium is, now we will write the formula. What is the formula? Half into sum of the lengths of parallel sides into height. That is half into, which are the parallel sides? PQ plus SR. So here two brackets are shown, length PQ, round bracket, again one bracket like this is given, that is SPQ and SR are added, that is length PQ plus length SR, and multiply by height, height is PM. So half into sum of parallel sides, which are PQ plus SR, into PM. Now we will substitute the value, half into 7 plus 13. One side is 7, other we got 13 into 4. Now BODMAS rule, that is solve the brackets. 7 plus 13, yes children, 20. 7 plus 13, 20 into 4. Now half of 20, so half of 20, 10. So 10 multiplied by 4. Yes children, 10 fours are 40. So it is area of quadrilateral PQRS is 40 square centimeter. So this is a challenging sum which we have done. So you have to do it 2 to 3 times. Then you will be able to find it easy. So how we have taken the right angle triangles, then it has become the how one rectangle, and we have found the length SR. So this sum, do it 2 to 3 times. You will be able to understand it. It is a challenging sum. Now this is an assignment for you. Lengths of two parallel sides of a trapezium are 7.5 cm and 12.5 cm respectively, and its height is 4.8 cm. Find its area. This is a simple sum, children. Yes. So what we will do? You will first write given. What is given? Length of parallel sides, which is 7.5 cm and 12.5 cm. Height is 4.8 cm. What you have to find? Area of trapezium. Solution. So first you will write the formula. So what is the formula, children? Area of trapezium? Yes, area of trapezium is equal to half into sum of length of parallel sides into height. Then you will substitute and solve and write the answer. So we will be concluding our session here, and we start next new knew this and you practice these sums, children, then only you'll be able to solve. Thank you, children. Have a nice day. Thank you.